Welcome to Knowledgegainer1M channel. Today our topic is exercise 10.3 of mensuration topic in 10th class. First question is, an iron pillar consists of a cylindrical portion of 2.8 meters height and 20 centimeters in diameter and a cone of 42 centimeters height surmounting it. Find the weight of the pillar if 1 centimeter cube of iron weighs 7.5 grams. According to the question, the image of the pillar is like this. The bottom is a cylinder with diameter 20 centimeters and the cylindrical height is 2.8 meters and the top part is the cone with 42 centimeters height. Here diameter is given as 20 centimeters. So the radius becomes 10 centimeters. Here the volume of the pillar is equal to volume of the cone and also volume of the cylinder should be added to that. First we should individually find out the volume of the cylinder and also the cone. For the cylinder, R is 10 centimeters and height is given as 2.8 meters. Converting this into centimeters, we should multiply it with 100. So we get 280 centimeters is the height of the cylinder. Now the volume formula is pi r square h. Let us substitute the values. 22 by 7, R value is 10. So 10 into 10, h is 280. 7 fours is 28. So 22 into 4000. We get the volume of the cylinder as 88,000 centimeter cube. Now for the cone, the base of the cone and the cylinder are same. So R is equal to 10 centimeters in the cone part also. H is equal to 42 centimeters is given. Now the volume formula is 1 by 3 pi r square h. Now substituting the values, 1 by 3 into 22 by 7 into R is 10 into 10 into height is given as 42. Cancellation, 7 6 times 3 ones 3 twos. 4400 centimeter cube is the volume of the cone. Now the volume of the pillar is found by adding these two values, that is volume of the cylinder plus volume of the cone. 88,000 plus 4400. On adding these two values, we get the value as 92,400 centimeter cube is the volume of the pillar. And finally, we should find the total weight of the pillar at the rate of 7.5 grams per 1 centimeter cube. Here for 1 centimeter cube, it is 7.5 grams. But the total volume is 92,400. So, this becomes 92,400 into 7.5. On calculating, we get 693,000 grams is the total weight of the pillar. Converting this into grams, we should divide it by 1000. On dividing it with 1000, we get 693 kg is the total weight of the pillar. The second question is, a toy is made in the form of hemisphere surmounted by a right cone whose circular base is joined with the plane surface of the hemisphere. The radius of the base of the cone is 7 centimeters and its volume is 3 by 2 of the hemisphere. Calculate the height of the cone and the surface area of the toy correct to 2 places of the decimal. Pi is equal to 3 1 by 7. According to the problem, the toy is in the shape of this. The top is the bottom with 7 centimeter radius of the base and the bottom is the hemisphere. Now let us write the information given in the question. Radius is given as 7 and the volume of the cone is equal to 3 by 2 of the volume of the hemisphere is given. Now the volume of the cone formula is 1 by 3 pi r square h and volume of the hemisphere is 2 by 3 into pi r cube. Cancelling 3 3 and 2 2, we get 1 by 3 pi r square h is equal to pi r cube. Here in both of this cone and the hemisphere, the r value is same. So cancelling 2 r's and 2 r's here, pi and pi, h is equal to 3r. But we know r is equal to 7 centimeters. So h becomes 3 into 7, that is equal to 21 centimeters is the height of the cone. The first part is over. Now we should find the surface area of the toy. The surface area of the toy is found by adding the surface area of the cone plus the curved surface area of the hemisphere. Now let us find the curved surface area of the cone and the hemisphere individually. For cone, r is equal to 7 and h is equal to 21. We should find the L value, that is 7 square plus 21 square. On adding both of this, 49 plus 21 square is 441, which is equal to root of 490, which is equal to 22.135 centimeters approximately. Now the curved surface area formula is pi r L. 22 by 7, r value is 7, L value is approximately we got 22.135. On multiplication, we get 486.990 centimeter square is the curved surface area of the cone. Now for the hemisphere, r equal to 7 centimeters. Now curved surface area of the hemisphere formula is 2 pi r square. Substituting the values, 2 into 22 by 7 into r is 7 into 7. Cancelling this, 44 into 7. 308 centimeter square is the curved surface area of the hemisphere. Now the surface area of toy we get by adding the curved surface area of the cone plus the toy, that is 486.990 plus 308. The value we get it as 794.990 centimeter square is the curved surface area of the toy. If you like my explanation, please like, share and subscribe to Knowledgegainer1M channel and also share with your friends. Third question is, find the volume of the largest right circular cone that can be cut out of a cube whose edge is 7 centimeters. According to the question, let us consider the cube of edge 7 centimeters. From this, a right circular cone of largest volume should be cut. So, the cone will be in the form of this. Now, the radius of cone becomes 7 by 2, that is 3.5 centimeters. As we cut the cone of the largest volume, the base of the cone diameter is equal to the edge of the cone, which is equal to 7 centimeters. So, as diameter is 7 centimeters, the radius becomes 3.5 centimeters. D is equal to 7 centimeters. From that, radius of the cone is 3.5 centimeter. Now, the height of the cone becomes the edge of the cube. So, h is equal to 7 centimeters because side of the or edge of the cube is 7 centimeters. Now, the volume of the cone formula is 1 by 3 pi r square h. That is substituting the values in this formula, which is equal to 1 by 3 into 22 by 7. R value is 3.5 into 3.5 and h value is 7. Cancelling 7 and 7, 2 11s. On multiplying all these values, we get the volume of the cone as 89.83 centimeter cube is the volume of the cone with the largest volume that can be taken out of the cube of 7 centimeters edge. Fourth question is, a cylindrical mug of radius 5 centimeters and height 9.8 centimeters is full of water. A solid in the form of the right circular cone mounted on a hemisphere is immersed into the mug. The radius of the hemisphere is 3.5 centimeters and height of the conical part is 5 centimeters. Find the volume of the water left in the tub. Take pi is equal to 22 by 7. Now, according to the question, there is a cylinder of radius 5 centimeter and the height of the cylinder is given as 9.8 centimeters. In this, an object is immersed of this shape. Now, the radius of the hemisphere is given as 3.5 centimeters and height of the cone outside the tub is given as how much? 5 centimeters is the height of the cone outside the tub. Now, we should find the water left in this tub after the dimension of this object. First, let us consider the cylinder, that is the tub part. Here, r is equal to given as 5 centimeters and height is given as 9.8 centimeters. Now, the volume is equal to pi r square h. Now, substituting the values, 22 by 7, r is 5 into 5 into h is 9.8. On multiplication of all these numerators, we get 5390 by 7. On cancellation, we get 7 7s is 49, again 49, 0. So, 770 centimeter cube is the volume of the cylinder. Now, let us move to hemisphere part. Here, radius of the hemisphere is given as 3.5 centimeters. Volume of the hemisphere formula is 2 by 3 pi r cube. Substituting the values, 2 by 3 into 22 by 7 into 3.5 whole cube. So, 2 into 12.25 by 3. That is 3.5 and this gets cancelled, 2 11s. So, we get the value as 269.5 by 3. This is the volume of the hemisphere cone part. For the cone also, radius is same, that is 3.5 centimeters. Height is 5 centimeters outside the cylinder is given. So, volume becomes 1 by 3 pi r square h. Now, substituting these values in the formula, 1 by 3 into 22 by 7 into 3.5 whole square into 5. Cancelling 3.5 to 11s, we get 192.5 by 3. Centimeter cube is the volume of the cone. Now the volume of the solid immersed is equal to the volume of the cone plus the volume of the hemisphere, that is 269.5 by 3 plus 192.5 by 3. On adding those two values, we get 462 by 3. On cancellation, 3 ones, 3 5 is 15, 3 4 is 12. That is 154 centimeter cube is the volume of the solid immersed. And finally, we should find the volume of the water left in the tub. That is the total volume minus the solid volume. Total volume of the tub is 770 minus the solid volume is 154. On subtraction, we get the value as 616 centimeter cube is the volume of water left over in the tub. Please like, share and subscribe to Knowledgegainer1M channel and also share with your friends. Press bell icon to get notified so that whenever I upload a video, you will get the notification. Fifth question is, in the adjacent figure, the height of the solid cylinder is 10 centimeters and the diameter is 7 centimeters. Two equal conical holes of the radius 3 centimeters and height 4 centimeters are cut out as shown in the figure. Find the volume of the remaining solid. Fifth one, in order to find out the volume of the remaining solid, first we should find the volume of the cylinder. From that, we should subtract the volume of the two conical holes. Let us first consider the cylinder. Here, radius of the cylinder, that is diameter of the cylinder, is given as 7 centimeters. So the radius becomes 7 by 2 or 3.5 centimeters becomes the radius of the cylinder. Now the volume of the cylinder formula is pi r square h. Pi value is 22 by 7. R is 3.5 into 3.5 into h value that is the height of the cylinder is given as 10 centimeters. H is equal to 10 centimeters is given. So 10 here. 7, 2 times, 1 10, 2 ones, 2 11s. Cancelling the point and the 0, this becomes 35 into 11. So 35 into 11 value is 385 centimeter cube is the volume of the cylinder. Now let us take the cone part. The radius of the cone is given as 3 centimeters and height is given as 4 centimeters. Now the volume of the cone formula is 1 by 3 pi r square h. Substituting the above values in the formula, 1 by 3 into 22 by 7 into r value is 3. So 3 into 3 into h value is 4. 22 into 9 4 is 36 by 21. On multiplication, we get 792 by 21. Cancelling this, 3 7s and 3 2 times, 6 times and 4 times. So 264 by 7 centimeter cube is the volume of one cone. As there are two conical holes, total volume of the two conical holes becomes 2 into 264 by 7. On calculating, we get 528 by 7 centimeter cube is the volume of the two conical holes. Now the volume of the remaining solid is volume of the cylinder, that is 385 minus volume of the two conical holes, 528 by 7, which is equal to 385 into 7 minus 528 by 7, which is equal to, on calculating, we get 2167 by 7, which is equal to, on calculating all this, we get 309.571 centimeter cube is the volume of the remaining solid. You should calculate all these values. If I calculate it in this video, it becomes very lengthy. So I am directly writing the answers. Now the sixth question is, a spherical marble of radius 1.4 cm are dropped into a cylindrical beaker of 7 cm which contains some water. Find the number of marbles that should be dropped into the beaker so that the water level rises by 5.6 cm. According to the question, let us consider the cylinder here. Its diameter is given as 7 cm. D is equal to 7 cm is given. So R becomes 7 by 2, that is 3.5 cm is the radius of the beaker. By dropping the marbles in this beaker, there is a rise in the water level. The rise in the water level is in the form of the cylindrical shape, and the rise is given as H is equal to 5.6 centimeters is the rise in the water level is given. And for this cylinder also, R is equal to 3.5. Now the volume of the water rise, because as this is a cylinder, we should take the formula pi r square H. Substituting the values 22 by 7 into R value is 3.5 into 3.5 into H value is 5.6 is given. So on calculating, 215.6 is the volume of the rise in the water level. Now the volume of the each marble. As marble is the sphere, we should take the volume formula of the sphere, that is 4 by 3 pi r cube. Here r is equal to, radius is given as 1.4, so r becomes 1.4 by 2. That is equal to 1.4 by 2 is 0.7 centimeters. Now the volume of each marble V is equal to 4 by 3, pi value is 22 by 7, and r cube. R cube is 0.7 into 0.7 into 0.7. On calculating all these values, we get approximately 1.4373 centimeter cube is the volume of each marble. Now rise in volume is equal to the total volume of the marbles, because as we are dropping the marbles into the beaker, there is a rise in volume. So rise in volume is equal to total volume of the marbles. Rise in volume, we got it as 215.6. Total volume of the marbles is, let the number of marbles be n. So n into 1.4373. So n is equal to 215.6 by 1.4373. On calculating, we get n, that is the number of marbles is 150. Here n is the number of the marbles dropped. Seventh question, that is the last question of exercise 10.3 is, a pen stand is made of wood in the shape of cuboid with the 3 conical depressions to hold the pens. The dimensions of the cuboid are 15 centimeters by 10 centimeters by 3.5 centimeters. The radius of each of the depression is 0.5 centimeters and the depth is 1.4 centimeters. Find the volume of the wood in the entire stand. Volume of the cube is equal to volume of the cuboid minus total volume of the 3 depressions. Now let us consider the cuboid first. The L is given as 15 centimeters and breadth is given as 10 centimeters and height is given as 3.5 centimeters. The volume of the cuboid formula is length into breadth into height, that is 15 into 10 into 3.5, which becomes 15 into 35. The volume of the cuboid is 525 centimeter cube is the volume of the cuboid. Now let us consider the depressions. The depressions are in the form of the cone. Now the radius of the depression r is given as 0.5 centimeters, that is the height is given as 1.4 centimeters. Now the volume formula is 1 by 3 pi r square h. Substituting the values, 1 by 3 into 22 by 7, r value is 0.5 into 0.5, h value is 1.4 is given. 7 ones and 7 0.2 times 22, we get 1.1 by 3 centimeter cube is the volume of the cone, that is for one depression. Now the total volume of the 3 depressions is 3 into 1.1 by 3, which is equal to 1.1 centimeter cube is the total volume of the 3 depressions. Now the volume of the wood is volume of the cuboid 525 minus volume of the depressions 1.1, which is equal to 523.9 centimeter cube is the volume of the wood. Thanks for watching. Please like, share and subscribe to Knowledgegainer1M channel and also share with your friends.